Welcome to the next unit. This is the unit where we're going to be graphing quadratics. So today we're going to look at the graph of a quadratic function. So the quadratic equations are written as y equals ax squared plus bx plus c, where the a value does not equal 0, so that this equation has a degree of 2. And the reason we say that the a value cannot equal 0 is because if the a value were 0, this 0 times the x squared would end up making this go away, and then we would just be left with bx plus c, which would really just be a line. So that's why the a value has to be not equal to 0. Now the graph of this equation is called a parabola, and it is U-shaped. Now the parabolas are functions because they pass the vertical line test, but remember that's not enough to say that it's a function. This means that each input has a unique output. Now I want you to take a minute, pause the video, and write down the observations that you can make about these two parabolas here. So what do you notice about these functions? Now, I just made a list of some of the observations students have made in the past. This may be different from your list, so add anything that wasn't included on yours. So I just wrote both are symmetrical, meaning that if we folded them down the middle, they would be the same on each side. Both have a turning point or a place where they start going the other way. So here I started going up, and then after this point up here, I start coming down. So that's a turning point up here. Both look like a U, but one is upside down. One opens up, the other opens down. One has a lowest point and the other has a highest point. So again, those are just observations people have made in the past. So these are the two types of parabola shapes that we will see. So let's talk about these some more. We have two different situations. We'll have situations where the a value will be positive, so that means the parabola will open upward, where the curve reaches a minimum point. And then we're going to sketch a graph to the side. So you can see in my picture, I just showed that the curve is upward, it's a positive a value, and you can think of it as kind of like a smiley face. When we have a positive a value, or things are positive, or we're happy, things are positive, we're going to be smiling. So that's another way people have used to remember what the graph may look like. Now, the opposite is when the a is negative. When the a is negative, the parabola opens down, and where the curve will reach a maximum point. And then we're going to sketch a graph again. And for this one, people tend to think of things being negative. If someone's being negative towards you or not very nice, it's going to make you sad. So then we have the frowny face. The parabola opens downward. Okay, so some more notes to fill in. All parabolas have a line of symmetry, and it's called the axis of symmetry. This is a vertical line that goes through the turning point, which is also called the vertex. So there's a lot of key words in there that we're going to come back to, and you're going to need to know what they mean. The axis of symmetry, which is that line that cuts it in half, and the axis of symmetry is where if I fold it down, the axis of symmetry, the paper, if you can think of it that way, that would make the parabola the same on both sides. It goes through the turning point, and you'll need to know that that point can also be called the vertex. We have a formula that can be used to find the axis of symmetry. Now, unfortunately, you're not given this formula, so you do have to memorize it. So the formula is x equals negative b over 2a. Now, if you're thinking to yourself, that sounds familiar, it is familiar. It is part of the quadratic formula. So the negative b in the numerator of the quadratic formula, and then the 2a in the denominator. So some people use that to help them remember the axis of symmetry formula. At the bottom, we have a question that says, what is the equation of the axis of symmetry of the parabola represented by y equals negative x squared plus 6x minus 4? Now, in order to find this, we're going to use our axis of symmetry formula. But to use that, I need to first identify the a, b, and c value. So go ahead and take a minute to identify those, pause the video, and see if you get the same values as I do. The A value is -1, B is 6, and C is -4. Now that we have those, we can go ahead and fill them into our axis of symmetry formula from above. So then I get x equals -6 divided by 2 times a -1. And remember to use your parentheses whenever we substitute values in. Now you have a few options to find this answer. You can either put this in as a fraction in your calculator if you're familiar with doing that. You can also put parentheses around what's in the numerator so that this happens first, and then put the division, and then again parentheses around the denominator to say that this needs to happen before I do the division. The other option is to just clean up the top and clean up the bottom. So I'm going to clean up the top and clean up the bottom because I think that's the easiest way for certain calculators. But if you're familiar with using the fraction, you can go ahead and do that now. Your answer should match mine. So this becomes -6 divided by -2, and then that equals 3. Now I'm going to rewrite it as x equals 3, and the reason for that is because then I know this is actually a line. So the axis of symmetry, remember, is a vertical line that goes through the turning point. So this is the equation of the line, the axis of symmetry. X equals 3. So that's my answer. The next page says that Kelly is asked to find the equation of the axis of symmetry for y equals -x squared minus 2x minus 1. She says that the answer is -1. Do you agree or disagree, and explain? So the important things here is we are told what Kelly thinks the axis of symmetry is. We need to find out if we agree or disagree and then explain why or why not. So first, let's go ahead and identify the A, B, and C values. So pause the video and give that a try. The values that I got are A equals -1, B equals -2, and C equals -1. Now pause the video and try finding the axis of symmetry using the formula on the previous page. So we start with the formula x equals -b over 2a. Then fill in the b and a value that we wrote above. X equals -2 over 2 times -1. So this becomes 2 divided by -2. So my final answer is x equals -1. So do we agree with Kelly? Well, I agree that the value is -1, but if we're talking about an axis of symmetry, I can't just say -1. I have to say x equals -1 to show that it's a vertical line that goes through the turning point. So -1 is the right value, but how she wrote it is incorrect. I wrote this as I disagree with Kelly because although the value is -1, the axis of symmetry is a vertical line, so it must be written as x equals -1. So here we see another vocab word, and that's the turning point. So the turning point is just another term for vertex of the parabola. So the vertex has the coordinates of x, comma, y, since it's a point where it starts going the opposite direction. So identify the turning point of the parabolas below. So the first one, we can just look at the graph here and see that the turning point is this place right here where the parabola starts going the opposite direction. So I can put a point right here to identify it. And then I just need to identify the x and y. So it's right 2 and up 1. So the coordinate would be 2, 1, and that is my answer. Now for number 2, we just have an equation here. So I have to try to find the turning point. So one option would be to put it in our calculator and look in the graph. But in case they ask you to do it algebraically, I'm going to show you how we can find this without going straight to the calculator. So if we think about what the turning point is, it is the place where the parabola starts going the other direction. We can call it a turning point. And we also know that there is that axis of symmetry that divides the parabola in half, and it goes through the vertex. So if I find the axis of symmetry, I can then use that x value to find the y. So how do you find the axis of symmetry? We're going to first identify A, B, and C. So A equals 1, B equals 8, and C equals 12. Then we can go to the formula, which we have written up above here, so I'm not going to write it again. negative b over 2a. So then I can sub in the b and a value into this formula. So x equals negative 8 over 2 times 1. And then we can clean up the top, clean up the bottom. So x equals negative 8 over 2, and then negative 8 divided by 2 gives me an x value of negative 4. So now I know the axis of symmetry. How does that help me to find the turning point? Because I haven't answered the question yet. Well, I know that the axis of symmetry goes through the turning point. So to find the point, I now know the x value. I know that it has to be on that line. So how do I find the y? Well, if we know x, we can find y by subbing the x value in place of x in our equation. So all I did was write out that y equals, and then I subbed in the x value of negative 4 in place of all the x's. And then we can just put that all in our calculator. When we do that, we get a negative 4 as an output. So that means that my answer is an x value of negative 4 and a y value of negative 4. So we write that as a coordinate negative 4 comma negative 4. And that's my answer for the turning point. Now, the reason we did that the long way is so that you know how to solve it algebraically. But if it's just a multiple choice question, you can always plug in the equation into y equals and look at the table or graph. It's important to know this though, because there might be times when the turning point is a fraction and it's hard to find on the graph in the table. Okay, so to find the turning point or vertex, we use the axis of symmetry formula, which is x equals negative b over 2a, to find the x coordinate, or we get it from the graph. Then we can substitute the x coordinate into the function to find the y coordinate. Let's look at this number 3 together. It wants to know what are the coordinates of the turning point of the parabola whose equation is y equals x squared minus 4x plus 4. So just to practice, we're going to solve this algebraically. So I'm going to start by identifying the a, b, and c value. A is 1, B is negative 4, and C is 4. Then we can sub those values, the A and B, into the formula for the axis of symmetry. So when we substitute them in, we get negative 4 divided by 2 times 1. Now remember, depending on how you use your calculator, you may be able to put this all in at once, but I'm going to go through step by step for those who need it. So negative 4 becomes 4, and then in the denominator, 2 times 1 is 2. Then I can do the division. 4 divided by 2 is 2. So I know the x value is 2, but I don't know the y yet. So if I know what x is, in order to find y, I can substitute that value in place of x in the equation. So everywhere I had an x in the equation, I subbed in my x value of 2 and used parentheses so that I can put it all in my calculator exactly the way I see it. When I put that all in my calculator, I ended up with 0. So that means that my turning point is an x value of 2 and a y value of 0. So that means option 1 is my correct answer here. Okay, number 4 says given y equals x squared plus 4x minus 3, we need to determine the axis of symmetry. So again, identify A, B, and C. So my A value is 1, B is 4, and C is negative 3. Then we can fill them into the axis of symmetry formula. When I sub them in, I get negative 4 over 2 times 1. So then we can simplify the numerator and denominator. So x equals negative 4 divided by 2, and negative 4 divided by 2 is negative 2. So x equals negative 2 is my axis of symmetry. Now we need to determine the turning point. Well, I've just done the work to find the x value for when the turning point happens, where on the x-axis. So now I got to find what the y value is. So I can plug the x in using parentheses. So again, remember your parentheses whenever we substitute the value in. So everywhere I had an x, I subbed in the negative 2. With the parentheses, I put everything in my calculator exactly the way I see it, and then I get the y value out of negative 7. Now that's not my answer, that was just the work to find the y value. So my answer is an x value, negative 2, and a y value, negative 7. So the turning point is at negative 2, negative 7. Now, the next question says, is the turning point a minimum or a maximum point? And we need to explain. We have a couple options for this. One would be to put it in the calculator and then look at the graph to find out. But the other option is to think of what I talked about on the first page. I said when we have a positive a value, the parabola is a smiley face parabola or opening upward. So if you can picture that, that means that it's going to start and then go down and then back up. So you can sketch the graph if you'd like, but that tells me that the parabola will have a minimum. And I wrote that saying that the turning point is a minimum because the a value is positive, meaning the parabola opens up and has a minimum. Okay, so that's it for today. You're going to try homework 1 tonight. Don't forget to reach out if you have any questions. Have a good night.